There's a black hole sitting more than 13 billion light years away that, according to the scientists who just measured it directly for the first time, should not exist. Not because it's too big, or too strange, or too far away, but because of the order things happened in. Every model we've ever built assumes galaxies come first. Stars are born, they live, they die, and some of them collapse into black holes that slowly grow inside an already existing galaxy. This one didn't follow that order. This black hole appears to have existed before the galaxy around it ever formed, and nobody currently has a clean explanation for how that's possible. This is the story of a discovery that's quietly forcing scientists to reconsider one of the most basic assumptions in all of astrophysics. Which comes first, the black hole or everything around it? I'm your name, and this is your channel. If real discoveries that shake up the textbooks are why you're here, subscribe now because this one is still unfolding. To understand why this matters, you have to understand what scientists thought they knew. For decades, the standard story of black hole formation went like this. Massive stars form inside young galaxies, burn through their fuel over millions of years, and eventually collapse under their own gravity, forming a black hole. Over time, through mergers, and by pulling in surrounding gas and dust, some of these black holes grow larger and larger, eventually becoming the supermassive black holes we find at the centers of galaxies today, including our own Milky Way. In this picture, the galaxy always comes first. The black hole is something that grows up inside it over a long stretch of cosmic time. The problem is, ever since the James Webb Space Telescope started looking deep into the early universe, that tidy story has been running into trouble. Webb has now detected thousands of supermassive black holes, objects millions to billions of times the mass of our Sun, existing in galaxies from less than 1 billion years after the Big Bang. That's a serious problem, because there simply isn't enough time in that window for the standard star collapse and slow growth model to produce something that massive. You'd need to start with a stellar collapse, then grow through mergers and accretion for a very long time to reach billions of solar masses. But some of these black holes are already that big when the universe itself is barely a toddler. This puzzle has a name in the field, the seed problem. Scientists have spent years trying to figure out what kind of seed a black hole would need to start from in order to grow this fast, this early. Was it a small seed that somehow grew unbelievably quickly? Or was it never small to begin with? That's where this new observation comes in. Researchers using James Webb pointed the telescope's NIR spec instrument at an object called Abell 2744 QSO1, nicknamed QSO1. One of a strange, abundant class of objects Webb keeps discovering in the deep early universe called little red dots. These little red dots have puzzled astronomers since Webb first spotted them in 2022. Small, extremely distant, oddly red objects that seem to be everywhere in the early universe, then mysteriously stop appearing after about 1.5 billion years post-Big Bang. Scientists have gone back and forth for years on what these things actually are. Baby galaxies under construction, unusual stars, or black holes wrapped in dense clouds of gas. For QSO1 specifically, earlier observations suggested it might be little more than a glowing cloud of hydrogen and helium gas surrounding a supermassive black hole, estimated at somewhere around 40 to 50 million times the mass of our Sun. But here's the catch. Every previous mass estimate for black holes this early in cosmic history had been indirect, based on assumptions borrowed from how black holes behave in the much closer, much more recent universe. Nobody had ever been able to directly confirm whether those assumptions actually held up at this kind of extreme distance. So the research team, led by scientists including Francesco Eugenio and Ignace Puig-Ballis at the University of Cambridge, decided to test it directly. If QSO1's black hole really was as massive as it looked, its gravity should show up clearly in how the surrounding gas moves, the same basic principle that lets astronomers measure a planet's mass by watching how it tugs on objects orbiting it. Using Webb's NIR spec integral field unit, they mapped the motion of the glowing gas, swirling around QSO1's center, tracking it in extraordinary detail for an object this far away. What they found was almost eerily clean. The gas wasn't moving chaotically or unpredictably. It was orbiting in what's called Keplerian motion, the same smooth gravity-governed motion that describes how planets orbit the Sun in our own solar system. That kind of precise, orderly rotation is only possible if nearly all of the system's mass is concentrated into a single, compact, dominant object at the center. Exactly what you'd expect from a genuine black hole and not from a diffuse or distributed collection of early stars. In other words, this wasn't circumstantial evidence anymore. This was, for the first time, a direct mass measurement of a black hole from the very early universe. And that measurement confirmed something remarkable. QSO1's black hole really is enormous, tens of millions of solar masses. sitting inside a host galaxy so small and so faint that, by every conventional model, it shouldn't have been able to produce a black hole anywhere near this size, this early. According to the research team, the implication is striking. This black hole likely didn't grow up slowly inside its galaxy over time. It appears to have been enormous from the very beginning, meaning it may never have gone through the small seed phase the standard model requires at all. Some researchers involved in this line of work have gone as far as suggesting these earliest black holes may have formed within the very first second after the Big Bang itself, before galaxies as we understand them had even begun to take shape. Think about what that actually means. The conventional order of cosmic construction, first stars, then galaxies, then black holes growing inside them, may not be universally true. In at least some cases, the black hole might have come first, massive and fully formed, with the galaxy assembling around it afterward, pulled together by the black hole's own gravity rather than the other way around. One of the researchers described this as nothing less than a paradigm shift, a total revisiting of the classical scenario for how black holes form and grow. That's not casual scientific language. When researchers use the word paradigm shift, they mean the foundational assumption itself, the one nearly every existing model was built on top of, may need to be rebuilt from a different starting point entirely. This isn't an isolated case either. Around the same time, a separate team used a different technique, tracking the motion of stars rather than gas, to directly weigh a completely different early black hole in a galaxy called MRG M0138, over 10 billion. Light years away, finding it to be roughly 6 billion times the mass of our Sun, and completely dormant, invisible in every wavelength of light. That black hole was found using gravitational lensing, essentially using the bent light from an intervening galaxy cluster like a natural magnifying glass to make a measurement that would otherwise be impossible at that distance. Two entirely different measurement techniques on two entirely different early universe black holes, both pointing toward the same uncomfortable conclusion. These objects were already surprisingly massive far earlier than existing models can comfortably explain. To be clear about where the science actually stands, this doesn't mean physicists are starting from scratch, and it doesn't mean anyone has fully solved the seed problem. What it does mean is that the easiest, most conventional explanation, small stellar mass seeds slowly growing over hundreds of millions of years, is looking less and less sufficient on its own to explain everything Webb keeps finding. Researchers are now seriously exploring alternative scenarios, black holes forming directly from massive collapsing gas clouds without ever going through a stellar phase at all, or exotic conditions in the first moments after the Big Bang that could have produced enormous black holes almost instantly. Here's the part worth sitting with. This isn't a science fiction premise. This is a direct, peer-reviewed measurement made using one of the most sophisticated instruments humanity has ever built, of an object whose light left it more than 13 billion years ago, meaning we are looking at it almost exactly as it existed in the earliest chapters of the universe's entire history. And what that ancient light is telling us is that our story of how everything, including the very structures that eventually made galaxies like our own Milky Way possible, actually began, might be missing a chapter we didn't know we needed. The team behind this discovery is already planning follow-up observations, hoping to find more objects like QS01 to figure out whether this is a rare oddity or a genuinely common feature of the early universe. If it turns out to be common, the implications reach far beyond one strange black hole. They reach into the fundamental question of how galaxies, stars, and eventually planets like ours came to exist at all. If you want to know what they find next, subscribe and turn on notifications, because we'll be covering it. Drop a comment with your theory. Do you think the black hole came first? Or is there something else going on that nobody's considered yet? And share this with someone who thinks we've already figured out how the universe began, because 13 billion light years away, the universe just told us we haven't.